If the Earth was a grape, then Saturn would be a grapefruit. Saturn's equatorial diameter is about 9.5 times larger than the Earth's, measuring at approximately 120,536 kilometers. While Saturn's acceleration due to gravity on its surface is 11.08 meters per second squared, larger than Earth's acceleration due to gravity at 9.8 meters per second squared.
Saturn revolves around the Sun in a counterclockwise motion, with its distance being 9 AU at its closest point and 10.1 AU at its farthest. It takes Saturn 29.7 years to revolve around the Sun.
While Saturn spins counterclockwise on its axis, its day is approximately only 10 hours and 47 minutes. This rapid spinning causes the planet to take the shape of an oblate spheroid, kind of like a flattened ball shape. This results in locations on the equator of Saturn being approximately 6,300 kilometers more distant from the center than the poles are.
Saturn's rotation speed on its axis depends on what part of Saturn you are talking about. Since the planet has a giant gas ball, different parts of the planet rotate at different speeds. There are 3 different systems for measuring the rotational speed of Saturn. System 1 is for the regions around the planet's equator. Here the rotation speed is about 10 hours and 14 minutes. System 2 is for regions above and below the equatorial belt. Here the rotation speed is about 10 hours and 39 minutes. System 3 is based on the rotation of Saturn's magnetic field. Here the magnetic field takes about 10 hours and 39 minutes to complete a rotation. However, the magnetic field was measured again in 2004 by NASA's Cassini spacecraft, and it found the rotation of the magnetic field had slowed down to 10 hours and 45 minutes, so the rotation in the system can apparently change over time. The atmosphere consists of hydrogen, helium, methane, and ammonia gases. Then there is a liquid layer of helium-saturated molecular hydrogen that gradually transitions to a gas with increasing altitude. Next is a thicker liquid metallic hydrogen layer that surrounds the interior core, which is suggested that it is similar to that of Jupiter, having a small rocky core. However, no one really is sure what the core is made of, as there is no definite evidence. The composition of Saturn is primarily that of hydrogen, helium, ice of ammonia, ice of methane, and water ice, and the core is suggested that to be made of rocky and metal elements.
The spacecrafts that have visited Saturn are Pioneer 11 in 1979, Voyager 1 in 1980, Voyager 2 in 1981, and Cassini-Huygens in July 2004. The Cassini spacecraft is scheduled to keep making observations through September 2017, when the craft will end its life with an intentional death dive into the ring planet's thick atmosphere.
Saturn has 62 moons, 9 of which do not have names. One of Saturn's moons, Titan, is the only other moon in the solar system besides Earth's moon that has been landed on by a probe called Huygens, which traveled with the Cassini spacecraft. After landing, Huygens took a detailed profile of Titan's nitrogen-dominated atmosphere, gathering temperature, pressure, and density readings over a wide range of altitudes. Huygens sent data to Earth from Titan's surface for 72 minutes before its batteries died and the probe went dark. This became the first spacecraft ever to land on one of Saturn's moons, and the furthest landing a spacecraft from Earth has ever made.
When Galileo was observing the planet Saturn in the 1600s, he noticed strange objects on each side of the planet and drew in his notes a triple-bodied planet system, and then later a planet with arms or handles. These quote-unquote handles were in fact the rings of Saturn.
There could be life on one of Saturn's moons, Enceladus. NASA's Cassini spacecraft recently discovered ice geysers blasting out of Enceladus' southern pole. This means that some part of Enceladus is geologically active, which is keeping the moon warm enough that water can remain a liquid underneath the surface. And wherever we find liquid water on Earth, we find life.